Hello, students. We are into chapter 12, section 4. Hey, look, it's the lake problem. Um, 12, section 4. And let's take a look at a couple of homework problems that we have for you today. And let's see here. 12.4, what did I do? 12.4, 1 through 11, then 13, 15, 16, 19, 22. Okay, so let's go 1 through 11. School pictures come in different sizes. Are the pictures similar to each other? Okay, one thing to remember with school pictures, really what we're talking about is we have to be thinking that this is a rectangle. Your school pictures come in rectangular form, guaranteeing that you will have all the angles that are congruent. That's not enough for similarity on a quadrilateral, but it's enough for you to be able to create ratios. So when you do this, when you're thinking about this, go ahead and say, okay, well, wait a minute. One picture is 8 by 10. The other picture is 5 by 7. So the long side would be, so it'd be 5 up here and 7 right there. Well, ask yourself, wait a minute, is 8 over 10, is that the same as 5 over 7? Is it? Let's check. 8 times 7, 56. 5 times 10 is 50. Oh no, I'm so sorry. These are not similar. If you've ever seen pictures like this, um, what they will do is, in order to kind of scale things up or down, is they will just make adjustments. So, and you may or may not have seen this. What they'll do is they will cut and they'll just like trim off part of the picture and you won't even see it. So if you have 8 by 10s or 5 by 7s made from the same picture, one of them is going to show like more of a shirt or more of your head or something like that, because they are not similar. I'll let you do the same for the wallet size, 2¼ by 3¼ All right. Let's see here. Crazy Horse Monument, South Dakota, 563 feet high. The monument is based on a 16-foot tall scale model. What is the scale? And they're really saying, when they say the scale, it really is the scale ratio. Okay, what is that ratio? Let's see here. Are the quadrilaterals below similar? Interesting. Well, let's see here. If they are, think about the properties. What makes two things similar? It's either side angle, side angle, side, or angle, side angle, side angle. And it looks like we've got side, angle, side, angle, side. Okay, so the angles are good because they're all 90. So angles are good. The sides need to be in proportion. So 4 is to 6, as 4 is to 6, that's good. As 6 is to 10. Ooh, I don't know about that one. Let's check. 6 times 6, 36. 4 times 10, 40. I'm sorry. No, the sides are not proportionate. Therefore, the shapes are not congruent. And that's what we're talking about, right? We're trying to get you to that stage. Consider parallelograms in which one angle. Oh, interesting. So they're going to tell you it's a parallelogram. Is that enough for you to conclude that the parallelograms are similar if you know one angle? I want you to figure that one out. I'm going to try that one. And I did answer in a separate video this one on two rectangles where the diagonal is twice as long as the other. Which of these are similar? Two rhombuses. Again, if you're thinking of rhombuses, you're already telling yourself the sides are going to be proportionate. Yes, you're right, but we've got to have more than that. Okay, so it's got to be side angle, side angle, side. Okay, so you're saying it's a rhombus, so the sides are good. Perfect. You got to get me two angles. If I have a rhombus and you have a rhombus, does that mean that we've got the same angles? Is that enough? Okay. What about two circles, two regular polygons? Two regular polygons is a good one. You gotta love that one. That might be like an always, sometimes, never type of question on a test that I write. Okay, let's continue on. On a piece of grid paper, draw similar but not congruent isosceles triangle. Not a huge thing. That shouldn't be a big one. I'll leave that to you. Which of the following pairs of triangles are similar? If they are similar, explain why. Okay, if they're similar, take a look. First one, they don't give me any angles. Angles are done. I've got to have side, side, side. Perfect. Check the sides proportions. Here, ooh, this is a good one. It's a good one right here. It's making me think, right? So if I look, what do I have? I see an angle and I see side, side, and a side, side. It looks like I might have side angle side, but you need to check the ratios. Make sure the ratios are the same. Do they form a proportion? Coming down here, I have an angle right here that matches. I'll just color it. That's the same for both triangles. One triangle is small, one triangle is big. And you may have enough information there for you to get there. 50 degrees, fantastic. And then don't forget about our amazing power of vertical angles. Thank you, Chapter 11, for giving us that. Number 8, in the following figures, prove the triangles are similar and find the measures. Okay, so you need to prove they're similar. You can use anything we talked about in this chapter. So again, if they are similar, the sides have to be proportionate with an angle in the middle. So this to me looks like a side angle side. Or if you could see that these are split, then guarantee this is the mid-segment theorem. Also, what do I have here? Angle and an angle, angle, yeah, angle, angle, and then set up your proportions for your sides. That sounds good. Now, you might look at this one and say, hey, this looks, Scott, this looks like side angle side. Well, let's take a look, shall we? Here's a number and an angle and then another number. Perfect. Notice it's this angle, the one with 2 tick marks. So when I go over here, I find a number, that angle, and the one I'm looking for has to be here, but there isn't one. So side angle side, if you said side angle side, that would not be correct. I don't have those pieces yet. Let's see here. C, what do I know? What do I know? Ooh, I've got side and side, side and side, and then maybe an angle at the top. Looks like side angle side. I'm feeling pretty good about that. If the sides are proportionate. Lastly, this one down here, I think I made a video on this one too, but let's just see here. Let me try this and see if this works for you. This angle right here is going to be blue, and this angle right here is going to be red. Okay. And what do I know? I know blue plus red plus 90 equals 180, right? So blue plus red plus 90 equals 180. Perfect. Now take a look down here at the bottom. What do I have? I have a red plus a 90 plus I don't know what, but it equals 180. So I have question mark plus red plus 90 equals 180. And if you look, everything matches up, which means, yeah, you got it. This other angle right here has to be blue. And if it is blue, that is all you need, because now you have a right angle and a blue angle. And those triangles will be similar. Look for those pieces. I think you're going to like them when you do. Find the value of X and Y. Okay. It does say things are parallel. Remember, if they're parallel, I get proportional segments. If I have proportional segments, I have similar triangles. So fantastic. Use that. Verify the triangles are similar. Totally up to you. Notice you do have parallel lines. If you have parallel lines, things are in proportion. And if they're in proportion, we get similar triangles. And then let's see here, draw a segment AB and use a compass and a straight edge to separate it into 3 congruent pieces. Very similar to what I showed earlier. I did it for 5 pieces in the video for the text part. But again, if you do one segment, then build a line, any line at all, totally your choice. And with a compass and straight edge, work your way out. And then I need my compass tool. Turn from that new one, put your pokey part in the new point. That will create a new point. And then come back and use your compass one more time. Put your pokey part here, measure out D, and you've got yourself basically 3, a 1, a 2, a 3 segments that will get you what you need. Last thing we do is we build a line segment here, and then we build parallel lines going off of that. You could copy an angle. You could make a rhombus. It doesn't matter to me. You've got tools to do that. And when you build those parallel lines, you will have cut your other segment into 3 perfectly congruent pieces. Look at that. I love math. All right, there we go. All right, let's see. I think I said 1 through 11. Yep, and then 13, 15, and 16. Let's go. Oops, wrong way. 13, 15, and 16. So 13. Oh, yes. We have triangles that are similar, and I give you the ratio. So if I give you the ratio between 2 of them, can you find the others? So I've done this one separately as a follow-up video. I want to give you the chance to do it here. If you haven't watched that video, try it, because these are proportions and percentages coming together. 19. And let's see, was it 15 and 16, right? 15, 16. Okay. If you copy a document, you should get a similar copy. If you want to reduce it to 1/6 of its original size, first you reduce it by 25%. In my mind, if you want to start with fractions, keep it fractions the whole time. So if you want to reduce it by 25%, that's 1/4. That means 3/4 is remaining behind. 3/4 times what gets you to 1/6. Okay. 16 is the height of a tree. And this is interesting. So the idea here is you stand kind of in line with the shadow and you walk towards the tree until the shadow that is being formed by your head, which normally would be kind of over here, as you walk, your shadow will kind of lay on top of the shadow from the tree. And you walk until your head touches just the exact tip top right there. See what I'm saying? And what you have then is you can guarantee yourself that this angle has to be congruent. And as you're standing straight up tall and the line over here is standing straight up and tall, we get 90-degree angles. You get really cool similar triangles, and you could use that to find the height of the tree. This is another one. To find the height of a pole. Lays a mirror on level ground 20 feet from the base of the pole. So this one is maybe looks a little bit different, but when you draw it out, so person standing, you lay a mirror on the ground, and then here's a pole over here that we're trying to find. Again, the ground is completely level. So when you look down, she can bounce off the mirror and see exactly to the top of the pole. Okay. Well, the angle of incidence is equal to the angle of reflection on a mirror. And so we get the fact that you're standing up 90 degrees, 90 degrees. If you know some distances here, you'd be able to find the height of the pole. All right. 15, 16, what else? 19 and 22. Let's take a look here. 19, in the following figure, identify similar triangles and find the length of DEA and the length of EA. DE and EA. Okay. So find the similar triangles. You need similar triangles. Hopefully you can see it. Each of them has a 90-degree angle and another angle. If you need a tip on this one, my tip will be this. Redraw the figure so that you have the big triangle and then the little triangle looking like they're along the same direction. So angle A is here, angle A is here, angle A is here. And then, so if you now look at them, angle A for both is right there. But now go over, the right angle is at E, the right angle here is at C. And so I have ABC and ADE. You'll notice basically I had to flip this a little bit so they match up. AD is 4. AB is 10. That helps me with the ratio. The other side over here, BC is 6. I don't know how big this one is. And up here, if you notice, you see AD is 4 and DC is 4, which means this side right here is 8. And so use the ratios that you have to find kind of X and Y. And again, that's my huge hint is to, when it gets kind of complicated like that, just take a step back and draw it. Okay, and I think I put this one in one of the videos as well, but this is similar to what was in the textbook. How could I make a rectangle? How can I make a square? All right. And so, yeah, remember a square. What is a square? A square is a rhombus and a rectangle combined. So once you solve what a rectangle is, go back and say, what was it for the rhombus that we actually talked about in the video from the book that was already used? It's in the textbook if you just want to look it up. And there you go. But again, if you're trying to prove parallelogram on something like this, especially with midpoints of sides, find, like draw, here's a great big triangle. Here is inside of that one, a smaller triangle. And guess what? Because I know this side right here and this side are the same, and this side is the same as that side, I know that I have side angle side similarity. If I have side angle side similarity, then what do I want to do? I'll do purple. Then this angle right here is the same as this angle right there, which means line VN is parallel to line ST. And if I'm trying to prove it's a parallelogram, that's one step. Repeat for the other triangle up top, and you will have it. Folks, that is it for the homework section on 12.4. I hope you bring your questions back this week. Don't forget we have a test coming up. Froggy, what do you say? Study for your test. Okay, Froggy's ready to go. He's happy. I hope you are too. Mando's back there looking out for us. If you need to meet with me, let me know. I can meet you on campus. I can meet you in person on Zoom. I can make another recording for you if you'd prefer that. A lot of times, and I'm not going to lie, it's better if we meet up where you can ask additional questions and follow-ups if something isn't as clear. Right now, I'm talking to myself the whole time, and for some of you, it may help really well. Others, you might be like, great job. Way to talk to yourself. I don't know what you're saying, but I don't know that you don't know. So help me help you, and we can get through this. All right, off you go.